Hello again. So this recording is for EQ3 of the water cycle and water insecurity. And EQ3 states, how does water insecurity occur and why is it becoming such a global issue for the 21st century? So a quick reminder, this is not a replacement of lessons. This is not detailed enough to constitute your entire learning of this topic. However, what it does do is it supports you in your extra reading and your revision, and hopefully therefore it is useful to you. So again, how does water insecurity occur and why is it becoming such a global issue today? So the first thing you looked at in this topic was what causes water insecurity. So there are physical causes and human causes. Now, the physical causes of water insecurity include climate, because of the precipitation amounts, which we looked at in EQ2. So the movement of water, the way it's distributed, etc. Evaporation rates and evapotranspiration rates are physical causes of water insecurity. Discharge amounts into the sea is another cause of water insecurity. And saltwater encroachment at the coast is a fourth cause of water insecurity. Now, in terms of the human causes, two things that are important here. One, contamination of water. So we contaminate water by our agricultural activity, industry, energy creation, for example, and domestic pollution in general. And also our over abstraction from rivers, lakes, and aquifers for human use of water is important too. So that over abstraction being a large factor, the amount of water we actually use causes water insecurity over a long period. Now remember, just as we looked at in EQ2, all of these problems, all of these causes of water insecurity are exacerbated by climate change and global warming. So climate change and global warming actually create another impact overall of water insecurity. Now, let's just think about supply and demand of water briefly. There is a mismatch between supply and demand, okay? And that's led to what's called water stress and water scarcity. So we have a total amount of available water on Earth, but because of rapid population growth and economic development, we have many countries experiencing water insecurity. This exists when there is less than 1,700 meters cubed per person per day of water. And that starts the mark of water stress. However, if we have 1,000 meters cubed per person per day, or under 1,000, what we have is water scarcity. Okay, so those terms, water stress and water scarcity, are given to you at the top of this slide here, and you can write them down and use them as definitions for each. There's places such as Saudi Arabia, Algeria, Syria, and they're experiencing absolute water scarcity. But countries like Egypt, Morocco, Kenya are between 1,000 and 500 in terms of meters cubed per day. So they're also on the way to experiencing large-scale absolute water scarcity. Even the UK and Spain and European nations are experiencing some vulnerability to water stress. So this is a large issue whereby demand far exceeds supply at the moment in the world, and with climate change and with increasing uncertainty of waterfall and rainfall and so on, this problem is likely to get worse. So what we have is finite resource and a rising demand. So increasing populations, people's living standards improving, are creating a rising demand, and this is leading to a higher risk of water scarcity. Now, rising demand is created by three key things. One, population growth. If there's more people, there's more thirst, there's more need for water. Two, economic development. If we have economies overall growing, that increases demand in almost all sectors for water, and that includes things like industry and agriculture. And third, if we have economic development, we have rising living standards and standards of living overall. And this means more people are cooking, bathing, cleaning, and using water for other things. as well as appliances like dishwashers, coffee machines, etc. And that leads to a rising demand for water. Now, we then need to think about the three main pressures on water. Okay, the three main things that are then causing insecurity on water. And actually, they're quite similar in a sense. So, supply, diminishing supply, climate change, deteriorating quality of the environment in terms of pollution, competition for water is making supply fall quite dramatically in the world. Rising demand, as we said before, due to population growth, development, living standards, is also creating water insecurity and pressure on water use. And finally, I mentioned before, competing demands from users and competition in general because of international issues, people upstream in a society versus downstream, the use of HEP versus irrigation, and so on. So competition also increases the pressure on water insecurity. Now, we've got two types of water scarcity. We've got physical scarcity and we've got economic scarcity. So let's start with physical scarcity. So physical scarcity basically occurs when more than 75% of a country or region's water, which is accessible, are being used. And that currently applies to about 25% of the world's population. So about a quarter of the world's population live in what's called physical water scarcity. So that would be countries in the Middle East and North Africa and other regions like China, Western USA, Southeast Australia. Okay, so physical scarcity is about the actual physical availability of water, the physical amount of accessible water falling. Whereas economic scarcity is the use of that accessible water being limited because of lack of money, lack of technology, lack of good governance, etc. So economic scarcity is actually a political thing, okay? It's to do with money and wealth and technology. So around 1 billion people in the world are restricted from accessing the water they can access because of high levels of poverty. This is most of the people living in Africa, apart from the extreme north and south. But there are also parts of Southeast Asia that cannot access available water because of economic reasons, because of lack of money, lack of technology, lack of good governance. So, therefore, the causes of water scarcity are twofold. There's a lack of precipitation on the one hand because of climate change, but there's also a lack of the actual ability economically to extract water. In the 21st century, today, it's increasingly being seen as a commodity for which a realistic price should be paid. So, water in the developed world, much of that supply is in the hands of private companies. People are expected to pay for water. However, it's also increasingly seen by some as a human right to have access to safe water that's drinkable, can be used to cook, and so on. So, just a quick roundup. Physical scarcity is all about the actual physical problems of accessing water, whereas economic scarcity is about the lack of money and technology to be able to access the water they have got. Now, water supply is extremely important for economic development and our general human well-being. So let's look at that importance. So for agriculture, for example, agriculture is a massive, massive industry in economic development. We know that most African nations, for example, are agricultural based and they rely on agriculture for economic development. So agriculture as a sector accounts for around 3,770 kilometers of water extraction each year. 20% of the world's land today is irrigated. In other words, it has to be watered by us to remain sustainable. And this is usually directly pumped from aquifers deep underground. However, this leads to massive underground depletion of water, like in China and the USA. And this is unsustainable. Okay, so currently agricultural water use or irrigation in the world is unsustainable, and we need to find other solutions in future for how we are going to conduct agriculture differently. Industry and energy. Okay, so businesses and energy supply and production. 20% of all fresh water that we have in the world, and if you think back to EQ1, remember the amount of fresh water we can actually access is only 1% of all the fresh water on Earth. Okay, so 20% of all fresh water is for industry and energy production. But the biggest problem is water pollution is a major product of this. So these industries and energy production companies create water pollution, and this is a major product of the use of that fresh water. Now, in terms of human well-being, there are three things I want you to think about, all right? When we talk about human well-being, what we're looking at really is our domestic use of water, our ability to use water domestically. Now, currently in the world, there are lots of places where water is polluted by a lack of sanitation, and water therefore becomes a breeding ground for disease and illness, like typhoid and cholera. And there are other debilitating illnesses created, such as malaria and dengue fever, and they are really detrimental to human health. So, therefore, what we're saying here is for human well being, clean water is absolutely vital for human health, to avoid disease, for cooking, for cleaning, for drinking, etc. So, in terms of human well being overall, and it's really related to economic development, it is really important that there is a clean, sustainable water supply. Now, you've got two case studies for this section of the topic for EQ3, and they're to do with players and conflict. Okay, so they're to do with conflict over water supply. And what I've done is I have summarized two of the case studies that you had a choice from. Okay, so first one on screen is an internal dispute. So within a region, within an area, it's local scale, and that is the River Nile. Okay, so this is just a few points that summarize the conflict itself. So water demand around the River Nile is increasing because of the reasons we've looked at before: population growth, economic development, and increased agricultural production. We know that global warming and water pollution are decreasing the availability of water, and therefore there comes a time where conflict happens over the use of the water and who it applies to, who owns it. In 1929, the Nile Water Agreement was set out, and this set out ownership of the water in the Nile, and it split it between Egypt and Sudan. However, the other countries that the River Nile runs through have no rights under the 1929 Water Agreement, and therefore this is where the conflict began. As years passed, countries started to gain independence. They fought for their rights over the River Nile and the water that it had. And as a result of this over extraction and the fighting of the rights of the water, what we've seen over time is a depletion in the water storage of the River Nile. And remember how vital the River Nile is to human life along it. Okay, that's why this is a really important conflict and dispute to think about. Now, water from the Nile is used to irrigate crops, and it provides millions with food through those crops. So it's used very much for agriculture. Tensions grew in ownership countries, Egypt, Sudan. And the reason the tensions grew was because of the use of the water by the other nations surrounding it that the 1929 agreement said they did not own. Therefore, the 1999 Nile Basin Initiative was launched, and this aimed to ensure efficient management, cooperation between all of the nations that the Nile runs through, and it targeted poverty eradication so that the water was not relied on as much. Now, a possible solution, this conflict is still ongoing, even though we've had numerous new agreements, but a possible solution to this conflict in future may include things like what Australia has done in EQ2 of this topic. So water conservation, harvesting rainwater and collecting it when it does rain, building mega dams to try and store water in areas, and also desalination on a large scale from ocean water. So that is a roundup of your local scale case study, the River Nile, in terms of conflict over water. Now, your second case study is not an internal dispute. This is a transboundary dispute. It's a large-scale dispute, and this is in the Mekong Delta. Okay, so the Mekong Delta and the Mekong River is the 8th largest in the world, and it stretches from Cambodia right out towards the China Sea. It's a very biodiverse river. It has 70 million residents living alongside it and along it, and therefore it's really important to those residents as a store of water and a use of water. Now, this is in an area in Asia of countries that have historical issues with conflict between each other. They have issues because of flooding over time along the river, and they have economic issues and development issues overall. One of the proposals that's been contentious, and this was a proposal by China, was to build 37 dams along the River Mekong to be able to more effectively store water for better use. And also, these dams would be hydroelectric powered, so it would also create energy. Now, what's happened is China's basically been criticized for this because they have not carried out efficient environmental and social impact assessments. Okay, so that's caused rising political conflict in the area. And as we know, China is a large superpower. So China's power over other nations like Cambodia in the say of what happens along the Mekong River is worrying to those nations. And that's what's caused the political conflict in this area. Now, to solve disputes like this, the Mekong River Commission created a Sustainable Development Initiative in 1995. And this initiative aimed to create economic prosperity, but also environmentally friendly cooperation between the nations along the Mekong River. And what it aimed to do is essentially promote sustainability, enhance cooperation, strengthen environmental assessments, and it also aimed to strengthen the Mekong River Commission itself as well, to try and sort out disputes about the Mekong Delta and the Mekong River between these nations. So that's an example of a political dispute that's taken place along the Mekong River in Asia as a result of diminishing water supplies and use of that water over time. Now, the next section of inquiry question 3 is to look at the advantages and disadvantages of hard engineering management strategies for water, or the ways in which we manage water in general. And there are 3. The first one's on screen for you, and they are water transfer schemes. And an example of this you looked at was the China Transfer Project, the China North-South Transfer of Water Project. Now, this creates a number of advantages and disadvantages. So for the source area, for where the water comes from, there is a drop of 60% in water flow. And obviously, this is a good thing in the sense that it decreases possible flooding. However, there is low flow, which increases pollution, and it impacts the ecosystem of the area, of the source area. And also, potentially in future, we could actually see increasing water scarcity in the source area because of climate change. However, in the receiving area, in the south, what we see is more availability of water means more usage, and that means increased development over time. However, we also see what's called unsustainable irrigation. Again, unsustainable use of water to irrigate for crop growth, etc. And what we want to try and do, obviously, as a world, is plan things sustainably for development so that we're not reliant too heavily on one method of crop growth. So that's the water transfer scheme of China. And it has a number of advantages and disadvantages as you've just seen. The next type of management strategy is mega dams. And an example of this is the Colorado River in the USA. So what this does is it diverts and holds water at a strategic area, which is really useful to stop flooding in some cases, but actually can cause flooding in other places too. One of the problems with this is that its capital costs, the actual amount to build it and then maintain it, are very high. What we get is high evaporation losses from the surface water that's stored. So we get increased evaporation amounts and therefore loss of water over time. What we also get is a disruption of the transport of silt downstream. So the water's natural flow in a river is disrupted, and therefore that disrupts the ecosystem overall. And actually, as well, what you get is displacement of people. People have to move due to construction ongoing, due to potential flooding downstream or upstream, etc. So that is some of the advantages and disadvantages of building mega dams. And an example of that is the Colorado River in the US. And then finally, we've got desalination projects. Now, desalination has taken off in recent years. It used to be only very small scale, but now we've got countries such as the United Arab Emirates doing it on a much larger scale. And the reason they're allowed to do it today on a much larger scale is due to technology improvements, such as the scientific method of reverse osmosis, which removes the salt water or the salt material from the actual water. Now, the good thing about desalination is there is an abundance of salt water available in the world. We do have an abundance of seawater, so there is no issue with the supply of the water for it. However, the process itself is very expensive. And whilst the process itself is quite sustainable and clean environmentally, it does have massive ecological impact on marine life. So it does impact marine life, fish stocks, etc. And that also creates further problems for sustainability in certain areas of the world. So they are the three types of hard engineering management strategies we've looked at in this scheme of work in EQ3. And they are really useful for an exam question on EQ3 that might ask you to assess the effectiveness of hard management strategies, hard engineering management strategies of water supply. Okay, so that's what they would be useful for. You could also be asked a 20-mark question evaluating these. Now, in terms of sustainable management schemes, which we've just looked at, I want to give you another example of one. Okay, so first of all, generic sustainable management options of water include things like smart irrigation, which is automated watering of crops and plants with water-saving sprinklers. We've got hydroponics, which is a different way of growing crops without soil in greenhouses that are controlled. We've got, as we mentioned with Australia and EQ2, recycling of grey water, so used water being recycled at low costs. And we've also got, as we mentioned earlier as well, managing water by harvesting it, collecting rainwater and using it for crop irrigation, etc. as well. So there are some generic sustainable management options for managing water. But I want to talk to you briefly about Singapore as a place which has sustainably managed its water supply, although there are some disadvantages to its sustainable management. So Singapore has few natural water resources, but it does have a thriving economy. It does have high standards of living. It does have high consumption rates of water. And this has made water management a top priority here because it has 6 million people living there. So water supply is crucial. And it's adopted what's called a holistic approach. And it's based on three key things. So Singapore has done three key things. Number one, it collects every single drop of water that falls. The government has various ways of encouraging citizens to use water sensibly. Since 2003, it's managed to reduce its water consumption from 165 litres a day to 150 litres a day. That's despite population growth. So that's a really good thing. Reusing water endlessly. Singapore has really cutting-edge technology, as is a highly developed nation, and it has developed new technologies to be able to reuse grey water again and again and again, for example, in toilets. And the third thing it's done is desalination of seawater. So it has 2 desalination plants, and they meet 25% of the water demand of the whole of Singapore. So there are three really key ways in which sustainable management has been successful in Singapore. This would be really useful to use in a 20 or 12 mark question assessing or evaluating sustainable management of water through sustainable management schemes. However, one key problem Singapore still has is this. Despite these actions, Singapore still has to import water from neighbouring Malaysia. Now, Malaysia has a higher supply of water because of the type of climate it's got. So therefore, even though these three strategies have been really helpful and useful, and even though desalination particularly supplies 25% of all of Singapore's water now, Singapore still has to import its water as well from Malaysia. Now, you may remember this from the topic, towards the end of the topic. This is Integrated Drainage Basin Management, or the IWRM approach. So the IWRM was first advocated in the late 1990s. And what it does is it emphasizes the river basin as a logical geographical unit for the management of water resources. So it uses river basins to manage water. It's achieved through cooperation of the players involved. The river basin is treated holistically. And three things are its aims. One, to protect the environmental quality of rivers, to use water with maximum efficiency, and to distribute it equally. Now, IWRM strategies do work well at community level. But the problem with them is they are community-based management strategies. So in larger river basins and international river basins, the problem is that the river basin is too large to undergo the IWRN type of strategy. Okay, so this is just to note that the IWRM is a really useful strategy holistically for managing a river basin and managing water supply and managing the use of that water and managing the players that use the water. However, if it's going to be large scale, it doesn't work as well because of international boundaries. And finally then, for EQ3, you looked at water sharing treaties and frameworks. And these are ways in which we can essentially legislate to manage water. Okay, so in spite of conflict, as we looked at earlier, international cooperation is the rule rather than the exception. And that means that generally international cooperation works very well across the world in terms of water. Even though there has been conflict, generally international cooperation is a success. There's only been a handful of military conflicts over drainage basins and over water supply in recent years. International cooperation generally works well, even between enemies such as India and Pakistan who share the Indus River. Now, there are a number of important international agreements on water basins and frameworks on water basins to make sure that water sharing takes place. And I've just named them here for you. I'm not going to go through each of them in detail. You don't need to know all of them in absolute detail, but I would suggest you should know at least one of them in good detail. So important international agreements include Helsinki Rules, the United Nations Economic Commission for Europe of Water Convention, the UN Water Courses Convention, and the EU Water Framework Directive of 2000. So what these international agreements do is they set in place clear rules for water sharing. They aim to avoid conflict and promote cooperation, and therefore it allows less conflict in the world over water supply. However, the one thing I would say about this is that there is the potential in future for water conflict to increase because of climate change. But because of these four particular treaties and international agreements above, the aim is to try and reduce those conflicts as much as possible. But we will see in future, obviously, how effective they are and whether they work or not. So that is the end of EQ3 for the water cycle and water insecurity. I hope you found it useful. Again, you can reuse this multiple times if you so wish, and hopefully you find it useful in reminding you of the key points of EQ3 in water and water insecurity.